In this video, we're going to show the full process for how you'll find all the real zeros for a given polynomial function. So the main theorem that we're going to use here is the rational root test, and that's going to start us out here. So we saw in the previous video that you look at the constant term, you see what goes into that evenly, 1, 2, 3, and 6. Then you see what goes in the leading term evenly, in this case, again, just 1. And you do all possible divisions here, and we get 1, 2, 3, or 6, positive or negative. And then what we're going to just try each one here. We're going to try using synthetic division. So we try 1, and so how synthetic division works, we put our coefficients here, 1, negative 8, 24, negative 34, 23 minus 6. We bring down, multiply by the number in the box, add down, multiply 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 the number in the box, add down, and if you get a 0 there, that means you found one of the zeros, you found a root. If you get anything other than 0, you cross it out and pretend you didn't do anything. However, I do want to point out something here. It is entirely possible for a number to have a multiplicity of 2 or 3 or 5 or something like that, which means that even though we found x equal to 1, that does not mean that x equals 1 isn't going to be an answer again. So we're going to try 1 again. However, for all future trials, we're going to use the reduced polynomial right here from the division. And each time you find an answer, you're going to use the more and more reduced version until it gets down to something simple enough that you can factor. So we're going to try 1 again for the second time and see what happens. So we say, okay, 1 brought down, multiply number in the box, add, multiply number in the box, add, multiply the number in the box, add, multiply the number in the box, add, and lo and behold, it works again. So we can go ahead and keep going on using this reduced version here. I'll try 1 a third time. It's possible that it has a multiplicity of 3. Bring 1 down, 1, minus 5, 6, and 6, and 0, and turned out it did actually have a multiplicity of 3. And then, at this point in time, the remaining polynomial is going to be just quadratic, x squared minus 5x plus 6. And in case you're not sure about that, we started with an x to the 5th here. That meant the first reduces down to x to the 4th, second reduces down to x cubed, and the third reduction is down to x squared. And once you get to x squared, you might as well just go ahead and factor it. And so, combining in the ones we had before, multiplicity 3, this then gives us all of the real zeros. So again, you start out by listing all the possible rational roots from the rational root test. You then start trying them individually using synthetic division. And then once you've found enough of them that you're down to x squared, either factor a quadratic formula to get the remaining ones.